Keagate is an open source cryptocurrency payment gateway that allows online platforms and e-commerce stores to easily integrate crypto payments into their site. It's super easy to get set up, and I'll demonstrate that along with send some test transactions to show how the payment lifecycle works. So with Keagate, you can utilize an API-driven approach or use the built-in invoicing client. And this here will show the API-driven approach, but I will do a video on the invoicing client at another time. So to get started and get Keagate running on your machine, you can use a couple different methods, and the easiest is the one-liner, which works on most popular flavors of Linux, but for a different configuration, the manual installation is also pretty straightforward. So I'm going to demonstrate on a AWS EC2 instance, and we call it Keagate demo. And with regards to the OS of this EC2 instance, I'll use any of the four here, so we'll stick with Amazon Linux. And instance type, we can use a pretty small one since Keagate is fairly lightweight. Key pair name, we'll select none, just so we can get started easily. And you definitely want to make sure that you allow both HTTPS traffic and HTTP traffic, because that's the method that we'll use to make requests to our instance here. And 8 gigabytes should be sufficient, but I'll just up it to 20. So let that launch. And the instance is now in a successful running state, so we can connect to it with this button up here. Typically, you'll probably want to use an SSH client, but since we don't have a key pair associated with this, which is not recommended in production, we can use this EC2 Instance Connect, which is like a built-in SSH interface. It's pretty nice and super easy to use, and this is my first time logging into this Amazon Linux 2 instance, and all we have to do to get the platform up and running is to copy this one-liner here and paste it. This will take a couple minutes to check and install some dependencies, and it will eventually finalize by bringing you to a command line interface. But while this is going, the destination of our currency is going to be in this demonstration with this simple hold browser extension I just installed, which is basically just a crypto wallet for different currencies. And in this video, I'm going to use Dash and Solana just because the transaction times are pretty quick, and that'll be good for demo purposes. But you can think of these wallets as basically your administrative wallet. This is where you want funds to end up, because Keagate is going to generate a one-time address each time a new payment is created, and then that wallet will observe its balance, and once that is beyond the set payment, then it will send it to you. So for each currency that you're going to want to accept, you're going to want to have a administrative wallet for that. So we'll wait for the installation process here to finish. So now the installation script has installed the required dependencies, and it's brought us to the configuration interface. And the first question basically is, which MongoDB instance would you like to point to? If you have an existing one, you can pass that via connection string or install one on the machine. So we'll do that. And it's going to install MongoDB via Docker, which is good if you're familiar with Docker. It's not necessary, but if you do have some familiarity with that, it'll be nice to be able to monitor what we have running. The next step is going to be the Nginx configuration. This is basically going to proxy our requests to our backend here, our Keagate backend. If you have a manual setup, you can use that, but it's easiest to let it configure it for us. Now, if you have a domain name pointing to your instance and you would like to be able to make requests to Keagate via that domain name and with SSL enabled, you would select yes here. you would have to have already have that domain name pointing to the machine. But what SSL is basically going to allow you to have to perform HTTPS requests, which is the standard for most web applications. I mean, is recommended for production, and that's going to give you that lockup here that we can see. For now, we're going to skip that. Now it's going to ask us which currencies we'd like to configure. The currencies that you configure here aren't final, so you can change them at a later time, but let's enable Dash and Solana. So it's going to ask for a public key of each of your currencies that you're configuring. So this is how Keagate knows where to send the funds to. So let's go and get our Dash address right there. We'll paste it. And it's also going to ask you if you would like to be able to send currencies from your administrative wallet with Keagate's API. This isn't required, but if it's a functionality that you'd like, you do have to pass in your wallet's private key, which is not sent anywhere, but it's utilized by Keagate to create these transactions. We don't need to demonstrate that right now, so we'll select no. Now, we've got to do the Solana public key as well. So now we can see that Keagate has successfully deployed on this machine. We can open our Swagger docs here at this address, which is nice. It'll be good to be able to visually see the API that we built out and also generate requests from here, but I'll come back to that. It's important to note that most of the administrative API routes require this Keagate API key, which is going to be, you're going to attach in the header of your requests. The script will automatically generate a random one for us. This, along with any other configuration options, can be changed in this config/local.json file. And if you ever make changes there, such as adding new currencies or changing certain parameters, after you've edited that file, make sure you run pm2 restart Keagate. pm2 basically just manages the node process of our backend instance. Really straightforward to use. You can read more up on that later. But what I will do now is to show you in pm2 the instance is running. Sometimes you have to close and reopen terminal for it to load a new path. But now we can see that we have in pm2 Keagate, you can monitor the instance with that command there, the monitor command, but you can read more up on that later. So let's go back to those configuration options because we're going to need them to make requests. So we'll go into Keagate here and we will display that local JSON file. Here's where you make changes to configurations. And what we'll need to do is to demonstrate the lifecycle of the API-driven approach is to take this Keagate API key and make sure that it's in the header of all our requests. So whichever client you're using to make requests, whether it be in code or with a tool like Postman or Hopscotch, make sure you set this in the headers parameter. Swagger has a really nice built-in way to do that. So I can actually paste it here and it will authenticate all the requests that we make. And note that that header, that administrative header, is only required for these 4 payment routes here. These invoice routes are publicly available and they're safe to be made public. They don't return any sensitive information. And in fact, this is how that invoicing client that I mentioned earlier functions. It uses these routes. But we'll start by creating a new payment. In Swagger, we can try it out. The schema of our request body is as follows. The only 2 required are amount and currency. Those are required for every create payment request. Amount, pretty straightforward, is the amount of the currency of the payment. And currency is the type of crypto that you would like this payment to be accepted of. So it's going to be the shorthand name, so like LTC or SOL for Solana. So let's try it out here. But note really quickly that since we're using the API-driven approach, we're going to want to use this IPN callback URL. IPN stands for Instant Payment Notification. And what that is basically a route that Keagate will send a request to every time the status of a payment is changed. So that's how we're going to be able to basically process and finalize transactions that you would normally. So if you had an e-commerce store, within this route is where you would, first of all, validate the authenticity of the request, which I'll get to, but also where you would do the sending of the merchandise, et cetera, et cetera. So let's create a new payment here. We don't need invoice callback URL, and we don't need extra ID, but let's start with a Solana request here. And on my phone, I have a wallet here with some Solana in it. So we'll make an amount of, we'll say 0.05. And we will set the currency to Sol. Now, before I get into this IPN callback string, I will just take that out for now. And we'll just make this request as is, so we can see kind of what the schema of the response is. This gives a successful response with some metadata, along with the public key. This is the destination where you want your customers sending their currency to. This is what's going to be observing its balance, updating status of the payment, and where your admin wallet will be receiving funds from. A new address is generated for each new payment that you create. So let me go back here and take this IPN callback URL parameter and reinsert it. So what you're going to want to put here is the URL of your server or function where you're going to be basically handling the business logic of the payment notifications. So this could be a API or a backend server that you're running with like Node and Express, or it could be a Lambda function. And I have a Lambda function here that I've already created. There's nothing really fancy in here. Basically, this is just printing what you've sent to it. Note that if we didn't authorize the payment that we just created in the Keagate API key header, this create payment wouldn't work. So to show that, I'll log out really quick and I'll send a new payment here. Amount 1 currency Sol. Try to execute it, and we can see that it's not going to work. So let me go back, reauthorize that with our administrative header. We'll reset this. We'll set the amount to 0.5. We'll set the currency to Sol, and we will set the IPN callback URL to the address of my Lambda function here. And now let's create a new payment. So we can see that the status is waiting. That means that the customer hasn't sent any of the currency yet. If they had sent some, it would say partially paid. If they've sent it all, it would say confirmed. And the way we can always get the status of our payments is by copying our ID and using the get payment status routes. So we'll try this one out. We'll paste the ID, and we can always be checking up on the status of a payment and just the overall metadata of a payment as well, right in there. But for now, let's take this payment here, and I'm going to, on my phone, send 0.5 Solana to this address. So I'm going to paste it on my wallet here. I'll send 0.5. So that should be heading now. Solana transfers are typically pretty quick, so it should be confirmed in a couple seconds at the most. I'll actually go back to that get payment status and we'll execute it. And we can see that the request is now confirmed. Take a look at our admin wallet. And there we have 0.5 Solana. The network fee was taken out. So now we've successfully confirmed our payment, and what we're going to want to do next is have our IPN consumer route not only validate it, but process a transaction as it normally would. So the first thing we have to do is take advantage of this IPN HMAC secret route. Basically, in a concise summary, this cryptographic function allows us to validate the origin of a request and make sure that nothing was changed in the middles from where the client sent it and where you're receiving it at your backend. This is super important for production because updates could be spoofed, right? If a malicious customer knew the IP and consumer route, they could be sending stuff to it. But with this cryptographic function, we can be sure that no requests are being spoofed. So in the Keagate documentation here, if we go to instant payment notifications, we can see an example of how to use that IPN HMAC secret to validate this requests. And your consumer will be receiving a request with a header set of x-Keagate sig. This is the signature that Keagate has calculated with that secret, and you have to calculate it as well and make sure that they're equal. So I'm actually going to just bring over a lot of this stuff into our function. In production, you probably shouldn't store the secret in plain text, but for demonstration purposes, this is good enough. Now, basically, we are going to use the crypto library, SHA-512, HTTP secret. We want to get the event. We want to get a body. We'll create a new variable called body, and that's going to be a object of the data that we've sent, or that Keagate has sent to you. So now that we have that, we can basically use it to not only sort the object as it is sorted on the Keagate's backend, but send it to this cryptographic function. And now we'll just check if the signature is equal to event.headers, this header here, then we're good to go. Otherwise, could be spoofed, and we shouldn't use the data as it has been sent. So if we're good to go, then we'll get the ID of the data that was sent over. And the scheme of the data that's sent over is going to look something like this, right? You're going to get basically all the data of the payment, including the status and other parameters that you've set. And we should be checking the status in this function. So we'll grab the status here. Now, if the status doesn't equal confirmed, then it's not finished yet. We're not good to go. So we could just log not ready yet. And end there. Otherwise, someone just paid for their service. So this is where you would put the actual logic of your own e-commerce site or SaaS or online platform. But we'll just log confirmed. We don't necessarily need any of this return data, since Keagate isn't using any of the data that's returned from your function, but we'll also log if it could have been spoofed maybe. So let's save that and deploy it to the cloud. And lastly, I'll do one more payment, this time with Dash instead of Solana. And we'll take a look at the logs of this function. So we'll go back to the create payment route. This time we will use Dash. We will only send 0.15, and let's see, it's here. Our IPN consumer likely already received a request with the status not of confirmed yet, but let me send that through on my mobile device. Let me send 0.15 dash. And I'll take that ID and I will get the payment status. So now the payment is confirmed here. We can look at our Dash wallet. And we can see that the funds have been sent. They haven't been fully confirmed yet, but in about 2 minutes, they won't just show up as having been sent, but will also show up in your wallet and be available for you to send. So now let's go to our IPN consumer and see the outputs that we got. So we'll open up the CloudWatch logs, the most recent one here, and we logged confirmed. So everything went through as normal. So that was how to use Keagate to accept currency. And for more information, the README has a lot of info on it. It's probably your best resource for further configuration and learning a little bit about how the backend actually works. That was all for this video, and thank you for watching.